Okay, so welcome guys back again to another video. In this video we are going to talk about the Malonic esters and their simple reaction. So I just want you to tell you that this video is going to be very short video, and I'm gonna target this video for the retrosynthesis analysis. So if you are not gonna based on retrosynthesis analysis, I mean if you are not on that stage, if you have not started the retrosynthesis analysis, then don't watch this video. You're gonna waste your time. So these Malonic esters are very important to the retrosynthesis analysis. So I'm going to talk about how we can use these Malonic esters as the reagents or as the syntones in retrosynthesis analysis, right? So otherwise, if you are not doing the retrosynthesis analysis, if you are not doing the advanced organic chemistry, then skip this video. This is not for you. Let's move on. So basically the Malonic esters means the structure is like this. You have ester group and you have a carbonyl group here, and here you have another carbonyl group. These are basically like 1,3 dicarbonyl compounds. Okay, here you have the 1,3 dicarbonyl compounds. The importance is this position. You know, there are two hydrogens here. Okay, these hydrogens are very basic, so not basic, these are very acidic. So when you make your medium little bit basic, you can remove these hydrogens and form a nucleophile, form a lone pair to act as a nucleophile. This is the key reagent here. This is the key point here. This Malonic esters, this particular carbon is very acidic. Okay, so you can form the nucleophilic characteristics for this carbon. Now you can react this with basically like the basic medium, let's say like this medium. So you can remove one of the hydrogens. Now you can obtain a nucleophile like this. This nucleophile can be used to react with electrophiles, right? Let's say you have a let's do this compound also. Sorry, you know that this compound has resonance structures, right? Let me draw the resonance structures too. And let's say here we have the ET, and you know this double bond can move to here to form the double bond, and this bond can break to form a lone pair. Now here we have the oxygen negatively charged, and here we have the double bond, we have the OET. Now let's say you have a alkyl group and a bromine here. So now this double bond here, it can go and attack to our R group because there's a leaving group here. This attack is facilitated by the formation of the double bond between the oxygen and carbon. Now you can obtain this particular compound. So with this attack, you know, bromine is going to be relieved, bromine is going to be eliminated. We have R group here. Okay, but the most important part is you can remove one of these ester bonds, right? One of these ester parts with heating with acidic medium. So now you can obtain ETO, carbonyl group, and this part is going to be eliminated, this part is going to be eliminated. You are left with the R group. This is more important, right? This is very important when it comes to retrosynthesis analysis, because you will see that these Malonic esters, right? These Malonic esters are the synthetic equivalents. Sorry, CH2COOH for this guy. This is a synthone, right? This is a synthone. These are the synthetic equivalents for this particular synthone. If this is very important when it comes to like this, you cannot use simple esters for this kind of molecules. You need to use some Malonic esters. These are much more reactive. Okay, so check out our playlist about retrosynthesis analysis. You will see more examples and application about all the possible problem types, how we can solve them, and we have discussed a lot about it. So check it out, and if you have any problems, feel free to comment below.